Hi, welcome to the demo of uh, Data Unificator. So as you can see here, is the start page of the OllaLab main that you download from the OllaLab link in GitHub. Once you're in the main page, just click on the Data Unificator and you will get here. And I got some sample data in this folder. So the first step is we click import. So this application is basically a Python Streamlit app for data science tasks. More specifically, it allows you to detect issues with data files and allow you to join data files. And data files can be any tabular format or any JSON or XML format. But in this demo, I'll just demonstrate with CSV format, which is a tabular. On the left here, you see several main steps of the process. We'll walk through the steps sequentially. If you have a big files, you can also adjust the CPU cores that the software will work with. The more cores, the faster it will perform. So after you import this, here we have two files. We have source one and source two. And for each source file, the first step is assign, you specify the data hierarchy. So we have columns in this case, we have columns in the data. And you can specify, the importance of the columns or the hierarchy of the columns. This is not a problem with JSON or XML file. In this demo, we just assign all the columns into the top level. So we're going to have a flat hierarchy. That's going to be the same thing for number two. And you can validate or not the hierarchy. But another interesting feature is the exploratory data analysis. So what this does is give you several reports on the statistic of the data that you just import. So the statistics are at different levels. So as we can see here, this is the basic statistic of the whole table. You can drill down to statistic of certain columns. For example, this is the statistic of the bytes in column. And if you want more details, you can scroll down to more details. It's going to give you more details about the data in this column, give you the illustration. So as you can see here, the distribution of the data in here is quite skewed and not normally distributed at all. You can see the common values here and especially the extreme values. And that's going to be the same certain types of report going to be available for each column. And besides that, we have report on correlation. So for example, and it is done automatically. So for example, the software automatically sense that the bytes in and byte out are statistically really correlate with each other. And here's a graph of it. And correlations also be presented as a heat map for easier viewing. Also available at table if you prefer more specific statistics. And missing values we don't have in here, and finally we have a sample rows of the data in the file. So after we are done with this step, we can go to the next step, which is the data mapping. So the data mapping is basically we have two files, right? So this step basically allow us to declare, if we want to join the two files, how we're going to map the columns of one file to another. So the first step in this phase is extract fields and metadata. Again, you will see some basic, metadata of the columns in two sources. And next, we ask the program to automatically identify the overlapping fields. Overlapping fields are important in joining the data files. And here we see that, there are three overlapping fields. And if we want, we can expand the description box to see more details. The source hierarchy is basically identify which one is the main one, higher priority. So basically, in this case, we have two files. The lower priority file field is going to be mapped to the higher fields. So finally, we have no, not finally, but next we have the creating of mapping dictionary. So this gonna be this gonna solidify the mapping schema. So we have overlapping fields and we have non-overlapping fields. And with non-overlapping fields, we will be either mapped to a new field or leave as is. So usually you map to a new field when you want to change the field name of the existing field. But from this demo, I'll just leaving as it is. So with the overlapping field, so the map to anchor field is basically we have two fields with two files with the same name, source IP in their columns. The anchor field is the column of the highest priority file that we specified above. So the action for the same name, column name from the lower priority file is mapped to the anchor field, and we're gonna specify the same field, the same name with the field with the same name in the first file. So this field in source 2 is going to be mapped to this field in source 1. Oh, actually, source IP, okay. And end time from file 2 going to be mapped to end time in source 1, and creation time from source 2 going to be mapped to creation time in source 1. And basically, we're going to save this specification, and align data structure is going to double check the data structure that we specified to make sure it's all good to go. And finally, this is going to save a temporarily merged files to disk. And here's the location. So after we save the temp files, we have the option to detect conflicts. So detect conflicts is actually detect the actual conflicts in the data itself. Before we just, check for the data structure, now we check for like the actual conflicts in the data. And if there's no incompatibilities and other issues, we can move to next steps. So in the data normalization, we have the option to standardize data format to handle data types, standardized, unit of measurements, um, outlier detection and handling. So here the software detected some outliers values. Some of the outliers are already presented in the earlier stage, but now it's here. We see it again in here, and in this phase, in this step, we have the option to deal with the outliers. So sometimes you're gonna need to remove the outliers, or set a capping value for that column. So with certain setting capping, some outliers will be removed, but some may fall below the capping value will stay, and do transformation, or just simply ignore the outliers. The field scaling is first you choose the field to scale, and then right now we have two options, as you can see here. And then we also have the fields aggregation and removal, just in case we wanna combine certain fields in the data, and the result of all those above actions will be displayed here again in the sample normalized data. And the duplication is, so after steps, we make changes. So we're gonna check duplicate rows again, and if there are duplicated rows, we're gonna remove it. And duplication criteria can be set to certain columns in the data. Like, by default, it's all columns, but you can also set, for certain columns, and if those criteria are met, we can choose what to do with it. And then finally, we have the option to save another file to the. And finally, in this final step, we have some report generation option again to do a quick check before we conclude the step. And some of the check, we've seen in the earlier step, but now we've seen again in this final phase for a final check. And that's it for the data unificator. Hope you enjoy it, and we'll try it out.